For this last question, it says that the integers 1 to 4 are positioned in a 6 by 6 square grid as shown, and they cannot be moved. The integers 5 to 36 are now placed in the 32 empty squares. Now we need to prove that no matter how this is done, the integers in some pair of adjacent squares, which means squares that are sharing an edge, must be different by at least 16. So, 16 is a very special number. We can see that 16 is 4 times 4, right? And now we have four numbers given. For each of them, they will have 4 adjacent boxes. So why don't we name them by the letters? Say A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. So, for A, B, C, D, they must, if I want to prove that they must be different by at least 16 with 1. It means that I want to find a way to show that it is not different by at least 16, right? Or basically find a way to prove that this can be done. So first of all, we will have A, B, C, D, take away 1, smaller than 16, which means I have A, B, C, D smaller than 17. And then we will have E, F, G, H, take away 2, smaller than 16, which means that E, F, G, H has to be smaller than 18. Now we have I, J, K, L, take away 3, smaller than 16, which means that I, J, K, L are all less than 19. And finally, we have M, N, O, P, take away 4, less than 16, which means that M, N, O, P are all less than 20. But now, we know that these are all different, right? And we can see that there are 16 numbers, which all of them are less than 20 if I want to make this work. But now, the 16 numbers on top of 4 is equal to 20, which means that at least one number is greater than or equal to 20. So it has a difference differs with 1 or 2 or 3 or 4 by at least 20, take away 4, that is 16. So that's how we can prove it. All right.